Hello everyone, this is Jason Baker and welcome to our hands-on segment covering elastic load balancing, ELBs. We use elastic load balancers to take incoming requests, oftentimes from the internet, and distribute those requests across a set of servers. You could think of this in terms of the horizontal scaling pattern that we discussed in the very first class in the course, where if we want to scale the performance of our web application, instead of buying and building a bigger web server, we just buy more web servers and we install our web application across a fleet of servers and then use a load balancer running in front of those servers to distribute requests, incoming requests, across all of the web servers. So that load balancer is a way it provides us with a mechanism to distribute traffic. It also can help support a highly available environment. The load balancer can detect if one of our web servers has failed, and if so, it can automatically route traffic and requests to other healthy web servers. That way, our service can withstand the loss of one or more servers. A load balancer can also serve as a sort of a security mechanism as well, in the sense that the load balancer intercepts requests that might be coming from customers on the internet, and then it will proxy those requests or hand them off, distribute them to the web server. So these customers on the internet are never communicating directly with our web servers. They're always going through a load balancer, and that load balancer is managed by AWS. It's going to be hardened from a security perspective. And so it provides sort of an additional security layer that we can take advantage of. In a production environment, it's very rare that I would launch an EC2 instance and make that instance directly available to somebody on the internet. Almost every case, I require that clients coming from the internet go through something like a load balancer in order to communicate with a web server. Well, let's look at setting up an elastic load balancer. And in order to do that, I'm going to first start by spinning up a couple EC2 instances that we are going to use with the load balancer. We're going to create a load balancer, and it's going to distribute requests across the two EC2 instances that I create. I'm already logged into the EC2 dashboard, and I'm going to go to the Launch Instances button. And instead of selecting the Amazon Linux 2 AMI, I'm going to select an AMI that I have already created. And this AMI is actually a publicly available AMI. If I do a search for it, I can just type in the AMI ID, and up pops the web server failover node AMI. This is a very simple Amazon machine image that I've created just for the purposes of simulating what happens with a web server running behind a load balancer. And this image is, as I mentioned, is publicly available, and you can use it as well. You might have to pause the video and record the AMI ID for your own use. We will also use this AMI a few times during the course of the class. I'm going to go ahead and select that AMI, and then I'll select the T2 micro type. That's fine. Click Next. A number of instances. We want to launch 2 of these. So instead of 1, we want We want to launch 2. And for our SSM, our IAM role, I'm going to do the SSM access. We're not actually going to be logging into these instances, so if you didn't include that, that's not a big deal. Everything else, I think, looks good. We're going to do next storage and next add tags. We might add a tag here, like a name tag. Name, we'll just call it web server. Configure security group button. And here we can configure a security group. We don't need SSH access, so we can remove that security rule. And we're going to add a new rule allowing HTTP access. And so custom rule, there we go, HTTP on port 80. And the source is going to be 0.0.0.0/0, which is, of course, the entire internet. So we're allow web access from internet for our description. We will review this and we'll go ahead and launch. Of course, we don't need a key pair, so we can acknowledge that we don't need keys. And we'll go ahead and launch those instances. I'm going to click on the View Instances button, and we'll watch as these instances launch. And while we're doing that, we can, while those instances are launching, we can start looking at the load balancer configuration. If I go into the load balancers link on the left-hand side, I can view a list of any elastic load balancers which are currently running, which there are none. And I'm going to go ahead and create a load balancer. Now, when I click on the Create Load Balancer button, the first thing that AWS asks me is, what type of load balancer do I want to create? And you see that there are a number of different options available. Years ago, there was only one type of elastic load balancer that was available, and that's now known as the classic load balancer. We generally do not use that anymore, and you can see that AWS has a note that says that they are going to be retiring their classic, what they call their classic network model in 2022. And so these classic load balancers are, really things that we try to avoid. We don't really use them anymore when building out new infrastructure. Instead, we choose either an application load balancer, network load balancer, or gateway load balancer. I don't cover the gateway load balancer really in this class, and I focus on application and network. And in this class, we pretty much only use the application load balancer. The application load balancer allows you to load balance web traffic for a website. So if you're running a web application with a web server, then you would choose an application load balancer. On the other hand, if you're running some other kind of application that's not a web application, that's talking on a different port and using a different sort of protocol, then you would use a network load balancer. I'll go ahead and select the Create button under Application Load Balancer. And it's going to ask me to provide a load balancer name. I'm just going to call it I'll call it the website-ELB. And it's asking me for a scheme, whether this is an internet facing or an internal load balancer. And in this case, it's an internet-facing load balancer. We want to take requests that are coming from the internet and distribute those to web servers. Now, we could also use load balancers within our application platform. It's sort of internally within our cloud environment. We're not going to, we don't really use that in this course. All of our load balancers are internet facing, but you have that option to create internal only load balancers. IP address type is going to be the IP4 in this case. For the network mapping, this is specifying which availability zones the load balancer will run in, and if it receives, if there are web servers running within those particular availability zones, then the load balancer can distribute requests to them. And so generally what I'll do is I will enable this for all of the public facing availability zones and subnets. Now, we haven't really covered that to a great degree in this class. So in this case, in this scenario, we're just going to select all of the different availability zones that are associated with this virtual private cloud. Now, security groups. For the security group, what we'd like to do is utilize that security group that I defined earlier, which actually was called Launch Wizard 11. Your security group might be called something different. I'm going to deselect this default security group. So I want to use the same security group that I defined for the web servers when I launched them. Next, we define a listener. And a listener is really defining, the port and protocol that the Elastic Load Balancer will listen for incoming requests on. You have this load balancer, it's listening to requests that are coming from the internet, and if those requests come on port 80 and they're using the HTTP protocol, which is the standard protocol that our web browsers use to communicate with web servers, then it will forward those requests to a target group. And a target group represents the set of web servers that the load balancer should distribute requests to. So you see, I don't have a target group defined, and so I can go ahead and create a target group. And when I do that, a new tab will open up and allow me to create a target group. Now, there are a couple different types of target groups you can define. In this case, I'm going to define a target group based upon a set of instances. I'm going to give that target group a name. I'll just call it web servers -TG, which stands for target group. These web servers are going to be listening on port 80, HTTP port 80 as well. I can define a few other things related to like the protocol version, which we're not going to worry about at the moment. We have selected the VPC with the instances in it that we want to use in the target group. And then for health checks, I'm going to expand this a little bit so we can see what's going on. The load balancer will perform a health check on a set interval. And the purpose of the health check is for the load balancer to understand whether a server that it's distributing requests to is healthy or not. Because if an instance isn't healthy, then the load balancer isn't going to try to distribute requests. And so in order to understand whether or not the instance is healthy, the load balancer does a health check, performs a health check, which is really like a web request. And in this case, the load balancer is sending a web request, so HTTP, to a particular health check path. So this is a path. Think of this as being like part of the URL, and the web server is going to send a request to the load balancer is going to send a request to the web server, and it's going to send it to a particular path on the web server. And this is the part of the document root path in the web server. In this case, I know that there is like the default home page for the website running on this web server is index.php. It's a little PHP application. And so if the load balancer sends a request to that particular path on the web server will respond back with some content, and it will respond back with a response code of 200, which means okay. In other words, the web server received the request and was able to respond to it successfully. And that's what the load balancer is looking for. It's sending these requests in a certain interval, which in this case is every 30 seconds. It's sending a request and asking the web server, are you okay? And the web server is responding back. I'm going to drop this interval down, by the way. I'll just drop it down to maybe 10 seconds. So that this demonstration is a little faster. And then there are a few other health check settings, like the healthy threshold and unhealthy threshold. With this number, the healthy threshold is saying, or let me do the unhealthy first. Actually, the healthy would make more sense. The unhealthy threshold, what this number is saying is that if the load balancer sends 2 consecutive requests to a web server and the web server doesn't respond properly to those health check requests, then the load balancer will consider the web server to be unhealthy and will stop distributing requests to it. So if we're checking every 10 seconds and there's an unhealthy threshold of 2, then after 20 seconds of not getting responses from the web server, the load balancer will consider it to have failed. The healthy threshold, what that's specifying is how many healthy, after a system has failed, how many healthy responses need to be received by the load balancer before it considers that instance to be healthy again. And I'm going to drop this down to maybe 3 in this case. So the load balancer would have to check 3 times over the course of 30 seconds with the instance and receive a successful OK message back from the instance before it would begin distributing requests to that instance again. Okay, I'm going to go ahead and click on the next button. And here it shows me the instances that are available within the cloud environment, the VPC that I selected. And you can see here are the 2 running web server instances that I launched earlier. And what I'll do is I'll go ahead and select both of those instances. So you see that 2 are selected. And we're going to be routing traffic to the selected instances on port 80. The load balancer is going to be receiving HTTP traffic on port 80, and then it's going to distribute those requests to these web servers on port 80 as well. Now, I've selected these instances that are available, but then I have to include them as targets. So I've selected them and I click the include as pending below so that they're now pending as targets. And I'll go ahead and create the target group. So I've successfully created the target group. If I do a refresh here, then I can see that that web server target group exists. I'll go ahead and close this tab. And now if I do a refresh here, you'll see that this web server target group resource is now available for selection. So if I scroll down, then I should be able to create the load balancer. So it tells me successfully created load balancer, and there's a note that says it might take a few minutes for the load balancer to start routing traffic. I'll go ahead and click on the View Load Balancers button. And here you can see that my load balancer is in a provisioning state. I'll click on this refresh button. It might take a minute or so before it's fully provisioned. It's relatively fast. A couple things to note on the description tab here for this load balancer. You can see a DNS name, and this is really important. This DNS name is the externally available endpoint for this load balancer. In other words, this is the address. This is the sort of the website address that we would use to send a request to this load balancer from our web browser on the internet. This DNS name. You can see, of course, that's internet facing. It's listening on all of these different availability zones. We're in US East 1, and US East 1 happens to have quite a few different availability zones. If I click on the listeners tab, then you can see that there's a listener on HTTP port 80. It's forwarding requests to the web server target group. Click on refresh here. It's still provisioning. I'll go to the listeners and click on this target group. Here you can see the target group. If I click on that target group, then it shows me the targets associated with that target group. You see the 2 web servers that are and we're going to be forwarding traffic to those web servers on port 80. And you see the health status. It says initial target registration is in progress. So these it's still provisioning that load balancer, and it is going to there we go. Well, it's going to then perform a health check to see if the web servers are healthy, and both of them are healthy, which is a great sign. That means the Elastic Load Balancer was able to successfully perform health checks against both of these EC2 instances, and they are now marked as healthy, meaning that the load balancer will distribute requests to these instances. Let me go back to the load balancers, the load balancer that we provision. And now you can see that the state is active. This load balancer is now running and can distribute traffic and requests. Let me copy this DNS name. I can do that by just clicking on this little icon to the right of that name. And I'm going to open up a web browser and paste that DNS name into it. And when I do that, a web page appears. Now, this is like a very simple looking web page, right? It's not fancy. All these web servers are really doing is they are responding back with a little message. For example, this message says, "Hi, I'm instance," and then there's an instance ID to denote that, which particular instance is responding to the request. Remember, each EC2 instance has its own instance ID. If I click refresh, then you'll see that the instance ID changes. The load balancer, and again, we didn't change the website address that we're communicating with, because we're communicating with the load balancer. The load balancer is taking our request and then distributing it to one of the two web servers that are in that target group. So if I just click on the refresh button a number of times, you'll see that it switches back and forth from one instance to another. And that's what elastic load balancers do. I mean, they're fairly simple sort of devices, but what they provide us with is absolutely critical. If we want to scale out our application platform, if we want to build a highly resilient platform, then something like an elastic load balancer is really an essential infrastructure service that we need to include in our architecture. Okay, I'm going to switch back to the previous tab. So everything looks like it's working great. Now what I want to do is I want to simulate a failure. What happens if one of these EC2 instances were to fail? And so if that happens, I'm just going to pick randomly one of them. I'll pick the second one in the list. And I'm going to say instance state. I'm going to go ahead and I'm just going to go ahead and terminate the instance. And we're going to, this is simulating an instance which has failed, right? So it's shutting down. And if I go back to my target groups, click on my web server target group and refresh the registered targets, now you'll see one of the targets disappeared. It's no longer there. And if I go to go back to my web browser tab where I'm hitting that load balancer endpoint, and I do a refresh, if I click that refresh multiple times like I'm doing now, you'll see that the message is always the same. The load balancer recognizes that one of the EC2 instances has failed. It's no longer there. It's been removed from the target group. The load balancer will no longer distribute requests to that particular EC2 instance. Again, very simple service, but absolutely essential to building out highly available application platforms. Now, to sort of unwind everything that we have done here, what you can do is you can go into the load balancers, and if you want to delete this, you can do an actions delete and go ahead and delete that load balancer. You can go into the target groups and you can, again, actions delete and delete that target group. And then finally go back to your remaining EC2 instance and terminate that instance. So that effectively unwinds everything that you created during this hands-on segment. I hope you enjoyed this, and I hope you're looking forward to the next hands-on segment. Thank you.